friends, a very warm welcome for the discussion pertaining to CSAT examination. Today's topic is clocks. Now you will find many questions based on this topic in previous year's CSAT papers and examinations of the similar stature. So let us begin with some basics here. As you can see on the top right hand side of the screen, there is a clock. Now, very basic fundamentals. It is known that one day has 24 hours and 1 hour has 60 minutes and 1 minute consists of 60 seconds. Also, very important for us to note here is the dial of a clock is divided into 12 large parts from 1 to 12. So these are called hour divisions. Now each part represents 1 hour duration, that is why they are known as hour divisions. Now the dial of a clock is divided into 60 small parts which are known as minute divisions, and each small part represents 1 minute duration. Now there are 3 needles or hands in a clock. This is hour hand, this is minute hand, and this one is seconds hand. These hands respectively exhibit the different time frames in terms of hours, minutes, and seconds. The angle between two consecutive hour divisions is 30 degrees. The dial of a clock is circular, or if at all it is triangular or square by nature, still the area which is traversed by these needles is circular. Now we know that the angle at the center of a circle is 360 degrees and the dial of a clock is divided into 12 hour divisions. So 360 degrees by 12 equals 30 degrees. As is evident here, this much is 30 degrees. The angle between this hour division between 1 and 2. Now similarly, the angle between two consecutive minute divisions is 6 degrees. Now this will be of lot of use to us while solving questions. Once again, we know that the angle at the center of the circle is 360 degrees and the dial of the clock is divided into 60 minute divisions. So hence 360 divided by 60 should give us 6 degrees. As is evident here, as you can see here, from this much to this much, it is 6 degrees of angle between the two hands. Now I have some questions for you. How many times do the two hands of a clock overlap, coincide, or form 0 degrees angle in 12 hours? Another question. How many times are the two hands of a clock at right angle or form 90 degrees angle in 24 hours? And the third one, how many times do the two hands of a clock form 27 degrees angle in 18 hours? Well, if you're done answering these questions, then let me tell you that you need to know a particular table which I am presenting in front of you. Now this is angle which can be represented by theta between the two hands of a clock. The duration is 12 hours or 24 hours. Now if the angle between the two hands happen to be 0 degrees or 180 degrees. Now 0 degree angle between the two hands would be when the two hands coincide or overlap one above the other, as it happens at 12 o'clock. 180 degrees is when the two hands are in a straight line, as happens at 6 o'clock. But these two hands are not overlapping. They're not one above the other. They're just pointing towards the opposite directions. And 180 degrees angle would mean that it forms a straight line. Now please remember that whenever the angle between the two hands of a clock is either 0 degrees or 180 degrees, this happens 11 times in 12 hours, which means it would happen 22 times in 24 hours. Any other angle, be it 90 degrees, 45 degrees, 33 degrees, 72 degrees, 60 degrees, whatever may be the other angle. It is formed between the two hands of a clock 22 times in 12 hours, which means 44 times in 24 hours. Now you must be wondering that why is it so that the two hands of a clock, they meet each other or form 0 degrees angle 11 times in 12 hours. It might have occurred to you that this phenomenon should happen 12 times in 12 hours, but it is not so. The reason behind this is that the hands of a clock meet or coincide every 65 by 11 minutes. How is it so? Well, I've already told you that the two hands of a clock, they meet each other or coincide or form 0 degrees angle 11 times in 12 hours. So, in 12 hours, there are 720 minutes, 12 into 60. If you divide this by these 11 times, then you would know that the two hands of a clock, they are coinciding every 65 by 11 minutes. So from 12 o'clock onwards, if you keep on adding up 65 by 11 minutes, you will find that there are 11 occasions when the two hands of a clock, they form 0 degrees angle. Now let us answer these questions. How many times do the two hands of a clock overlap, coincide or form 0 degree angle in 12 hours? Well, 11 times. How many times are the two hands of a clock at right angle or form 90 degrees angle in 24 hours? 90 degrees, as we can see, is any other angle. In 24 hours, it is formed 44 times. How many times do the two hands of a clock form 27 degrees angle in 18 hours? 27 degrees angle is any other angle. So, in 12 hours, 27 degree angle should be formed 22 times. In another 6 hours, it should be formed 11 times. Now 12 plus 6, you have 18 hours, and 22 plus 11 is 33. So in 18 hours, 27 degrees angle or 33 degrees angle or 54.6 degrees angle will be formed 33 times. Now in 4 hours, how many times do the two hands of a clock form 90 degrees angle? And we are given various choices here as 7 times, 8 times, 7.5 times, or 7 or 8 times. Now you must know this, that 90 degrees angle is formed 22 times in 12 hours. In this, if we see various 2 hours intervals from 12 to 2, 90 degrees angle is formed 4 times. From 2 to 4, it is formed 3 times because of an integer value that will occur here, that is 3 o'clock. So once 90 degrees angle is formed between 2 and 3, second time it is formed at exactly 3 o'clock, and third time it is formed between 3 and 4. That is the reason why here the number of times that 90 degrees angle is formed got reduced to 3 times rather than 4 times. Now similarly, from 4 to 6, 4 times. From 6 to 8, 4 times. From 8 to 10, again 3 times because of another integer value timing, and that is 9 o'clock. So between 8 and 10, 3 times 90 degrees angle will be formed. First time between 8 and 9, second time exactly at 9 o'clock, and third time once between 9 and 10. Then 10 to 12, again 4 times. So now if you add these up, 4 plus 3 is 7, plus 4 is 11, plus 4 is 15, plus 3 is 18, plus 4 is 22 times. And when you read the question, this 4 hours interval is not described. It is not given. So if at all these 4 hours happen to be from 12 to 4, then in that case, 90 degrees angle will be formed between the two hands 7 times. If at all this 4 hours interval is from 4 to 8, then as you can see here, 4 plus 4, the 90 degrees angle will be formed between the two hands of a clock 8 times. So 7 or 8 times because this 4 hours duration has not been specified to us. Had it been given from 12 to 4, how many times 90 degrees angle can be formed between the two hands of a clock? Then your answer would have been 7 times. Had it been given between 4 and 8 o'clock, how many times the two hands of a clock form 90 degrees angle? Then your answer would have been 8 times. So 7 or 8 times would be the correct answer here. Now look at this question. At what time between 4 and 5 do the two hands of a clock form 90 degrees angle? Now you have to find out these timings, and you know, between 4 and 5, 90 degrees angle should have been formed between the two hands of a clock exactly 2 times. So there must be 2 timings between 4 and 5 o'clock when the two hands of a clock form 90 degrees angle. Now how to find out these 2 timings? Now in such a case, please know this, that such kind of questions have been asked very frequently in CSAT and other examinations. And for this, I give you a very simple formula, and that is theta is equal to 30h minus 11 by 2m, and these 2 bars would indicate that we need absolute value. That is, the value obtained here cannot be negative. So theta, as you know, stands for the angle between the two hands. H stands for the hour value, and M stands for the minute value. Now to find out the angle between the two hands, we will use this formula. But when the angle is given and the hour value is given, and you have to find out the minute value, and you know that 90 degrees angle will be formed twice between 4 and 5 o'clock, you will write this formula twice. One in the forward order, second time in the reverse order, like this. Theta is equal to 30h minus 11 by 2m. Theta is equal to 11 by 2m minus 30h. Well, theta is already given to you, isn't it so? That is the angle between the two hands, which is 90 degrees. So I will just substitute 90 here in place of theta. Now our value is known. Between 4 and 5, timing would be 4 hours and something minutes. 4 hours 15 minutes, 4 hours 20 minutes, 4 hours 30 minutes. So the hour value here is the starting hour between the range which has been given to you. That is between 4 and 5, the 1 hour range which is given to you, or 1 hour duration. In this, the hour value is going to be 4. It cannot be 5. Between 4 and 5, you cannot have a timing 5 hours and 23 minutes. You cannot have that. But between 4 and 5, definitely you can have 4 hours and 23 minutes. So between 4 and 5, in all the timings, the hour value is going to be 4. So hence, H here happens to be 4. So let us substitute it here. So it is equal to 30 into 4 minus 11 by 2m. Well, minutes value is what we have to find out. Similarly here, 11 by 2m minus 30 into 4. Now let's solve this. It shall become 11 by 2m is equal to 120 minus 90, which is equal to 30. M here becomes equal to 30 into 2 by 11, that is 60 by 11. This 60 by 11 is equal to 5 by 11. Hence, the very first timing when the two hands of a clock will form 90 degrees angle will be at 4:05 5 by 11. Now, roughly, this is how it would seem on the dial of a clock. Let us say something like this. So this is the first timing. Now let us find out the second timing. So 90 is equal to 11 by 2m minus 30 into 4. Hence 11 by 2m becomes 90 plus 120, that is 210. So m equals 10 into 2 by 11, that is 420 by 11. Now this works out to be 11 threes are 33, 42 minus 33 is 9, 90. So 38 2 by 11. That is the minute value. So the second timing here works out to be 438 2 by 11. This is a timing when the two hands of a clock are at right angle. Now let us view it on a dial, a kind of a rough image that I would give you here. So 3, 4, 5, 6, 7, 8 and 9. So this is how it should look like roughly. 438 2 by 11. So these are the two timings. Now what is it that we need to keep in our mind? Theta is equal to 30h minus 11 by 2m. And then you can rewrite this in reverse order to find out the second timing. So you can write it in any order, but obviously the value has to be positive. If it is not coming out to be positive, then please reverse the order. Now, what will be the angle between the two hands of a clock at 7:30? AM or PM doesn't matter. So there are two ways of finding it. One I have already told you, that is through formula, and that is theta is equal to absolute value of 30h minus 11 by 2m. We need to find out theta. So it is 30 into, at 7:30, 7 is the hour value and 30 is the minute value. So 30 into 7 minus 11 by 2 into 30. We'll take the absolute value here. So this becomes 30 into 7 is 210. This goes minus 15 into 11 will be 165. So 210 minus 165 is 45 degrees. That is our answer. Now there is another method by which you can find out the angle between the two hands of a clock when a particular timing is given to you. Now you remember the clock, the analog clock, 7:30 looks something like this, right? Now see, how much is the angle between the two hands of a clock in 1 hour duration that we discussed? Between 6 and 7, there is 30 degrees of angle. Then from 7 to halfway. Why halfway? Because 7:30 is a timing at which half an hour has already elapsed after 7 o'clock. So the hour hand, which has to move from 1 hour division to the next hour division, it does so in 60 minutes. So in 30 minutes, the hour hand should be midway between 7 and 8. So hence, midway between 7 and 8 will give us a 15 degrees angle. So from this, you can find out that the angle between the two hands is 45 degrees. So this method will definitely work out for various ways. Let us say at 8 p.m. you need to find out. So if this is the dial 12, 3, 6 and 9, this will become 8, this will become 7. So this is how we have the 8 o'clock timing. You can simply calculate the number of hour divisions here. From here to here 1, this is the second hour division, this is the third hour division, this is fourth hour division. So 4 into 30 degrees, it will be 120 degrees. Or else you can also apply this formula, that is theta is equal to 30 into 8 minus 11 by 2 m. Minutes value here is 0. So theta here is 30 into 8, which is 240 degrees. Now obviously we can't have 240 degrees as the angle between the two hands. So we should look at 360 degrees minus 240 degrees. That will give us 120 degrees. So either of the two methods can be adopted. But when the timing which is given to you is not a multiple of 10, let us say 7:30 or 8 o'clock, the minutes value is a multiple of 10. But what will be the angle between the two hands if the timing given to you is 9:37? Now this needs to be worked out only through this method, but not through this. That is actually trying to find out the amount of degrees of angle between the two hands, because it will be very difficult for you to find out the exact position of our hand at 9:37 or even at 9:35. So that is why it is suggested that few timings like 8 o'clock, 8:30, 9 o'clock, 9:30 or 6:15, these you can find out using this method, that is manually calculating the degrees of angle between the two hands. But when the timing given to you may not give you an exact answer in terms of 45 degrees, 60 degrees, 120 degrees, 90 degrees kind of a thing, or the minute value is not a multiple of 10, in that case, please make sure that you use this formula. At what time between 6 and 7 do the two hands of a clock coincide? Coincide means what? They form 0 degrees angle. They are overlapping one above the other. In such a case, what do? You know that between 6 and 7, 0 degrees angle will be formed only once. So hence, theta is equal to 30h minus 11 by 2m. 0 degree occurs only once, so we will write it only once. So the angle here is 0. 30 into, now 6 has to be the hour value, the first one, minus 11 by 2m. So 11 by 2m equals 180. M equals 180 into 2 by 11, that is 360 by 11. 360 by 11 is 11 into 3 is 33, 30 remaining. So 11 2s are 22, so 8 remaining. So this timing has to be 6:32, 8 by 11. That is a timing between 6 and 7 o'clock when the two hands of a clock, they coincide, forming 0 degrees angle. Now this would look somewhat like this. This will be the position at 6:32, 8 by 11, roughly 6:33. Now talking about 0 degrees angle, there might be a question that arises in your mind, that why is it that 0 degrees is formed 11 times in 12 hours? Well, if you look at the dial of a clock, then please know this, that in every 1 hour duration, 0 degrees angle will be formed once, except a particular 2 hour duration when 0 degrees angle will be formed only once. Now, between 1 and 2, one time, 2 and 3, one time, and so on, every time here, in each of these hour divisions, you would find that the two hands are coinciding once or forming 0 degrees angle once. But between the time frame 11 to 1, the two hands of a clock, they form 0 degrees angle exactly in between, that is at 12 o'clock. Between 11 and 12, you will not find the two hands of a clock coinciding. Between 12 and 1, you won't find the two hands of a clock coinciding. But exactly at 12 o'clock, the two hands of a clock coincide. So this is the special timing, that is 2 hours duration, when the two hands of a clock form 0 degrees angle only once. And that is why in other 10 hours, 0 degree is formed. And in this 2 hour duration, from 11 to 1, 0 degrees angle will be formed only once. And that is how we get the number of times as 11. Now similarly, at 6 o'clock, the two hands of a clock, they are in a straight line, or they form 180 degrees angle between them. Now there is a special timing, that is 7 and 5. In this 2 hour duration, 180 degrees angle is formed only once. Apart from this, every 1 hour duration, you will find that 180 degrees is being made once, except 7 to 5, this 2 hour duration. So this is a kind of a special timing, you can say a special time slot, during which the formation of an angle differs from the other time slots. And this usually will be a integer value of the timing. Now similarly, we saw 3 o'clock and 9 o'clock. The two hands of a clock, they form 90 degrees angle. So once again, between 2 and 4 o'clock, 90 degrees angle should have been formed 4 times in 2 hours. But between 2 and 4, it is formed only 3 times because of the special timing having integer value, and that is 3 o'clock. So kindly keep this in your mind that this would happen for any kind of an integer value timing. Now, at what time between 9 and 10 are the two hands of a clock in a straight line but do not coincide? That means theta here has to be 180 degrees. They are in a straight line and do not coincide, do not overlap. So straight line will mean something like this. So let us apply the formula. Theta is equal to 30h minus 11 by 2m. So 180 is equal to 30 into the R value will become the first hour point between 9 and 10, and that is 9. So 30 into 9 minus 11 by 2m. So we have 11 by 2m is equal to 30 into 9 is 270 minus 180, which gives us 90. So m here is equal to 90 into 2 by 11, that is 180 by 11. So 11 ones are 11, 7 remains, joins with 0, so 70. So 11 6 are 66, 4 by 11. So the timing here is 9, 16, 4 by 11, and some of you thought it is 9:15. Well, it is not. And we are talking about 180 degrees, which is formed only once in any 1 hour duration, except between 5 and 7 o'clock when 180 degrees is formed, once in 2 hours duration. Now look at this question. Such kind of a question has appeared in CSAT examination as well. Now, at what time between 5 and 6 are the two hands of a clock 3 minutes apart from each other? So we have the formula theta is equal to 30h minus 11 by 2m. Now see, h is already given to us, and that is 5. Between 5 and 6, the hour value will always be 5. Minutes you have to find out because he's asking you at what time. So it is going to be 5 hours and some minutes, m minutes. So how much is the value of m? Is theta given to us here? Is theta given to us here? Well, yes. We already know that the two hands of a clock are 3 minutes apart from each other. Now we know that between two consecutive minute divisions, the angle made by the two hands of a clock will be 6 degrees. So when the two hands of a clock, let us say, are 3 minutes apart, then obviously the angle between the two hands is going to be 3 into 6 degrees. Every 1 minute is 6 degrees angle. So 3 minutes apart would mean that there are 3 hour divisions, and between each hour division, the angle made is 6 degrees at the center of the clock. So hence, theta is very much known to us. It is 18 degrees. So it is also known. Now let us substitute these values. 18 is equal to 30 into 5 minus 11 by 2m. So 11 by 2m equals 150. 30 into 5 is 150 minus 18, which is 132. So m becomes 132 into 2 by 11. That is 264 by 11. 11 into 2 is 22. 4 remaining joins with another 4. So 44. 11 4s are 44. So it is at 5:24 that the two hands of a clock are 3 minutes apart from each other. But then, as I told you, this is 18 degrees. That is, any other angle apart from 0 degrees and 180 degrees is formed 22 times in 12 hours. So there might be another timing. Let us say 5:24 is not given to you amongst the choices. Then what do? Well, you rewrite this formula as theta is equal to 11 by 2m minus 30h. So this becomes 18 is equal to 11 by 2 minus 30 into 5. Now look at this. 11 by 2m is equal to 18 plus 150, that is 168. So m here equals 168 into 2 by 11, that is 336 by 11, which is 11 into 3 is 33, Remainder is 0. Take down 6, not divisible by 11, so goes by 0. So 36 by 11. So the second timing here is 5 hours and 36 by 11 minutes. Now let me give you a rough diagram here. This is 12, this is 3, this is 9, this is 6. This shall be 4, this shall be 5. So we can say here that the two hands are 3 minutes apart from each other. Now similar kind of thing happens or can be viewed at 5:30, 6 by 11 hours. Now we know that two hands of a clock meet every 65 5 by 11 minutes, which we discussed is equal to 720 by 11 minutes. What is this 720? There are 12 hours and each hour consists of 60 minutes. So hence 12 into 60 is 720. And the two hands of a clock, they coincide or they form 0 degrees angle 11 times during 12 hours. Now let us talk about some faulty clocks. What would be meant by a faulty clock? A faulty clock is the one which does not show you the correct time. And what do you mean by a clock not showing you the correct time? Well, the time shown by the faulty clock will either be ahead of the actual time or behind the actual time. And this often happens with clocks or watches, be it a wall clock or an analog watch which we set using a knob, or even in a digital watch. So here I have a faulty clock for you. The two hands of a faulty clock meet each other after 65 5 by 11 minutes. That means let us say that they meet every 66 minutes. Now this watch is going to be fast or slow? Obviously this is going to be a watch which is slow. Why slow? Well, the two hands of a clock were supposed to meet each other every 65 5 by 11 minutes. But the two hands took longer time, 66 minutes, to meet each other. So as they have taken longer time, that means the clock is moving slowly. So this is a clock which is moving slow. So if at all it is moving slow, it will be ahead of the correct time or behind the correct time. Well, because it is slow, it should be behind the actual time. So the time shown by this clock is lesser than the original time. So let us say the original time is 1 p.m. and this clock is showing 12:50. Let's take up another faulty clock. The two hands of a faulty clock meet each other before 65 5 by 11 minutes. Let us say 64 minutes. So the two hands of the clock were supposed to meet each other or coincide every 65 5 by 11 minutes. But in this clock, the two hands coincided after 64 minutes. That is much before 65 5 by 11. So this clock must have been fast. And if at all it is fast, then it will show you time which is before or after the actual time. It will be after the actual time because this is running fast. So the time shown by this clock will be ahead of the actual time. Faulty time. Now what is faulty time? We took two examples in the last slide wherein the two hands of a clock did not meet after every 65 5 by 11 minutes. They met either after 66 minutes or at 64 minutes. So these 66 minutes and 64 minutes, which are not equal to 65 5 by 11 minutes, are the faulty times. So faulty time is any other duration in which the two hands of a clock meet each other apart from 65 5 by 11 minutes. So let us see, the two hands of a clock meet every 64 minutes. Well, they were supposed to meet in 65 5 by 11 minutes. So here we can say the faulty time is 64 minutes. Now this clock is fast or slow? 64, here is less than 65/5 by 11. That means the two hands are meeting much before 65/5 by 11 minutes. They are meeting earlier. And if they are meeting earlier, this watch will be fast. And if it is going to be fast, it will be ahead of the actual time. Now, similarly, the two hands of a clock, let us say they meet every 67 minutes. Now, 67 here is greater than 65/5 by 11. Now, this 67 is faulty. The two hands were supposed to meet at 65/5 by 11 minutes. Any other duration apart from 65/5 by 11 minutes will indicate a faulty time. So as 67 is greater than 65/5 by 11 minutes, that means more time has been taken by the two hands of a clock to coincide. In such a case, the clock is going to be slow. It is taking more time to cover the same distance. So hence, this clock will remain behind the actual time. So if at all we need to find out that by how much time a faulty clock is ahead or behind the actual time, then you can always make use of this formula. That is the number of hours which are given to you into 60, which are nothing but minutes, and the faulty time which is given to you. Let us say the two hands of a clock meet every 64 minutes or 67 minutes. So that is the faulty time, into the difference between 65/5 by 11 and the faulty time. How to apply this? Let's have a look at a question. In a clock, the minute hand crosses the hour hand in 65 minutes. Well, in how much time the minute hand should have crossed the hour hand? It should have crossed or met in 65/5 by 11 minutes. Instead, it crossed in 65 minutes. Now you know 65 here is less than 65/5 by 11. So the clock is going to be fast or slow? Fast. The two hands met before the scheduled time. So hence, the clock will exhibit a timing which is ahead of the correct timing or original timing. Now the question says, in one day, the time shown by the clock is how many minutes more or less from the original time? So first of all, it will be more or less. It will definitely be more because it is a clock which runs fast. Now see, the number of hours is also given to you here. When you say ahead or behind, that shall be equal to hours into 60 by faulty time into 65/5 by 11 minus faulty time. So this shall be one day. So hence 24 hours into 60 by faulty time, that is 65 minutes. So divided by 65 into 65/5 by 11 minus this faulty time, that is 65. We have here, we have a 24 into 60 into, well, this is by 65 into 65/5 by 11 minus 65 will give us a 5 by 11. So anyhow, this goes by 13. 13 into 5 is 65. And this becomes 1440 by 143, which is 10 by 143. So clock will be these many minutes more or ahead of the actual time in 24 hours. The time shown by a clock is 5 minutes before the actual time at 8 o'clock on a Sunday morning, and shows a time 5 minutes 48 seconds ahead of the original time on the next Sunday at evening 8 o'clock. So at what time did the clock show the correct time? Now these are the choices which are given to you here. Thursday 7:20 a.m., Wednesday 7:20 a.m., Thursday 7:20 p.m., Wednesday 7:20 p.m. Now when you look at the choices, one thing is certain, that the actual timing is 7:20. Whether AM or PM, we will have to find out. First. Second, it's going to be a Wednesday or a Thursday. We will have to find that out. Now see, Sunday 8 a.m. to next Sunday 8 p.m. Well, Sunday 8 a.m. to next Sunday 8 a.m. will be 7 days. Now from 8 a.m. to 8 p.m. on a Sunday is going to be another 12 hours. So this duration from Sunday 8 a.m. to next Sunday 8 p.m. shall be 7 days and 12 hours. In one day we have 24 hours. So 7 into 24 plus another 12 hours. So 180 hours in total. Now you have one Sunday here 8 a.m. to another Sunday here 8 p.m. Now on this Sunday 8 a.m. the clock was 5 minutes slow because it showed a timing which was 5 minutes before the actual time. And on this Sunday 8 p.m. the clock was 5 minutes and 48 seconds ahead of the actual time. So that means from this to this, clock in this 1 week, that is 7 days and 12 hours, has gained 5 plus 5 minutes and 48 seconds, that is 10 minutes and 48 seconds. It was 5 minutes slow. After a week, it is 5 minutes 48 seconds fast. So it was minus 5. Now it is plus 5 minutes and 48 seconds. So hence, the clock has gained from 5 minutes loss to 5 minutes 48 seconds gain. So the total time by which the clock has gone ahead is 10 minutes and 48 seconds. Now let us convert these 48 seconds into minutes. Now we know that there are 60 seconds in a minute. So this shall become 48 by 60 minutes. Now both 48 and 60 are divisible by 12. 12 into 4 is 48 and 12 into 5 is 60. So here we will write the clock goes ahead by 5. So 5 4 by 5 added to 5. 5 plus 5 is 10. So it shall become 10 4 by 5. This is a mixed fraction. You open it. 10 into 5 is 50 plus 4 by 5 works out to be 54 by 5. Now the clock gained 54 by 5 minutes in 180 hours. So the clock will go 5 minutes ahead or gain just 5 minutes, not 10 minutes and 48 seconds. Clock gains 10 minutes and 48 seconds in 180 hours, 7 days and 12 hours. So it will gain 5 minutes, that is lesser. In how many hours? And why 5 minutes? Because it was behind by 5 minutes. The clock showed a timing which was 5 minutes lesser than the actual timing. So if the clock will gain 5 minutes, it will show you the exact time. After that, it may still go ahead or become fast. Anyhow, what we need to find out is when did the clock gain this 5 minutes loss. So simply, so it becomes 5 by 54 by 5 into 180. You resolve this, you get 5 into 5. This 5 goes up in the numerator into 180 by 54. So these figures, numerators and denominators, they cancel by 18. So 18 into 10 and 18 into 3. So 5 into 5, 25 into 10, 250 by this 3. Now 250 by 3 works out to be 83 1 by 3 hours. Well, how? You divide 250 by 3, gives you a 10 here, goes by 8, goes by 9, 1 remainder. So 83 and this 1 is remaining, so 1 by 3 hours. Now how much is 1 by 3 hours? 1/3 of an hour has 60 minutes, so 1/3 of that will give us a 20 minutes. So 83 hours and 20 minutes. Now 83 hours and 20 minutes means how many days and how many hours and minutes? So 83 hours and 20 minutes we divided by 24 hours. Now you know 24 into 3 is 72. So 83 hours and 20 minutes we divided by 24 hours goes by 3 gives us 72 hours, becomes 11 hours and 20 minutes as the remainder. So 3 days and 11 hours and 20 minutes. Now which is the third day from Sunday? Monday, Tuesday, Wednesday. So Wednesday at 7:20 p.m. If it would have been 12 hours, then it will become 8 p.m. But it is 11 hours and 20 minutes, that is 40 minutes before 12 hours. So hence, Wednesday 7:20 p.m. shall be our correct answer, which is given to us in choice D. Now look at this question. In a clock, the time is set right at 8 a.m. After 24 hours, the clock shows a time which is 10 minutes ahead of the actual time. Means it shows how much? After 24 hours, it should have shown you 8 o'clock. It is showing you 10 minutes past 8. Now, what will be the actual time when the clock shows 1 p.m. the next day? Well, the actual time has to be before 1 p.m. because the clock is fast. So, the time shown by the clock when it is 1 p.m., the actual time has to be lesser than that. The clock has already gone beyond the actual time. These are the choices that we have, and we will have to figure it out. Now, it is already given to us that in 24 hours, the clock moves ahead by 24 hours and 10 minutes. Because after 24 hours, the time shown is 8:10 a.m. instead of 8 a.m. So the clock has gone ahead in 24 hours by 24 hours and 10 minutes. Now this 10 minutes, is 10 by 60 if you convert it into hours. Zeros cancel. So 24 into 6 is 144 plus this one is 145 by 6. Now we also know that the total time duration till next day 1 p.m. is 29 hours. 8 a.m. to 8 a.m. is 24 hours. So from 8 to 1, another 5 hours. So 24 plus 5, 29 hours. Now when time covered is 145 by 6 hours, as we found out here, in actual, only 24 hours is covered. When the clock has gone ahead by 10 minutes, it has covered 145 by 6 hours, and the actual time that had elapsed was 24 hours. Now, when the time covered by the clock will be 29 hours at 1 p.m., then what will be the actual time covered? So simply it should be 29 by 145 by 6 into 24. 6 goes up. So on resolving this, we get 29 into 24 into 6 by 145. After calculation, you can find out that this comes out to be 28.8 hours. Now, 0.8 hours here would mean how much? 0.8 into 60 will be nothing but 48 minutes. So 60 here is minutes, right? In 1 hour, there will be 60 minutes, as we know. So we are converting 0.8 hours into minutes. Works out to be 48 minutes. So 28 hours and 48 minutes, which would mean from 8 a.m. on the first day, we count 28 hours and 48 minutes. So 24 hours will be 8 a.m. on the next day. Another 4 hours is going to be 12, and then we have 48. So the timing here will be 12:48 p.m. on next day when the clock is showing 1 p.m. So when the clock shows 1 p.m. the next day, the actual time is 12:48 p.m. and this clock is fast. Alright guys, so this was a discussion about a topic clocks, on which questions have appeared on numerous occasions. So please do revise this, as this topic has lots of varieties. We will meet again in the next discussion on another topic. Till then, I wish you all the best. Stay safe, and thank you so much.